Today in this video we will start a new chapter, that is atoms. With science it was a biggest confusion that what is the tiniest particle in the universe, or when we take an object and cut into small pieces, till which extent we can go to get that smallest particle. Okay, so all these questions have led to a biggest concept in physics, that is discovery of an atom. Now, many scientists have came and given their conclusions or their points about the structure of atom. And the first person who has given his postulate was Thomson. But before that, with experiments, it was able to prove that the basic fundamental unit that build all the object, that is atom, that consists of positive and negative charges. I'll repeat, before the structure has been given by different scientists, it was able to conclude that the atom consists of positive and negative charges. Now, Thomson has given his first idea or his first structure about the atom, that is these positive and negative charges are spread in an atom like plum pudding model, like plums in a pudding. So here in India I can take an analogy of a cake, a plum cake, and having nuts in it. So these nuts and other raisins can be represented as positive and negative charges, that is spread across but with no order. Okay, so positive and negative charges in this way. 4, 3, yeah, 1, 2, 3, 4, 5, 5. Okay, but there is a biggest problem here. Now, if they are arranged in this way, why can't the positive being attracted by other negative charges, and why can't these negative and positive attract in between and combine together to nullify their effect? So for example, here these two will nullify, this will nullify, this will nullify, and these two will come closer, and basically the atom will collapse. So there is no stability for the model that suggested by Thomson. Now later Rutherford has came and given his postulates. According to Rutherford, he has told an atom consists of, yeah, same thing, positive and negative charges, but the positive charges are concentrated at the center and negative charges are around the positive charges. So there is no particular arrangement, there is no particular experiments made to prove that this statement is correct. He has told one thing, that positive charges are at the center and all the positive charges are at the center, electrons are spread across it. But with Thomson's model, positive and negative are mixed up in a plums in pudding model, but according to Rutherford model, it is not in this way, positive at the center and negative charges around, that is electrons are around. Now after many years, his students Geiger and Marsden has done an experiment to prove Rutherford's model. Now before that, let me give you an example of a sheet made up of atom. So let's say this is a thick sheet. Now this consists of a lot of atoms. So if atoms are arranged in this way, it is very difficult to understand the structure of an atom. For example, if you want to know what is inside this pen, inside this marker, the only way is hammer it and see what is inside. So similarly, if atoms are packed in this way, we can't segregate an atom and see what inside. So Geiger and Marsden, what he has done to understand the structure, they have taken a gold element, a gold foil. So that is a thick gold foil, and they have hammered it. So it's not the mechanical hammering what we say. It's with using machineries, they were able to reduce the thickness from this to this. Now see, what is the difference? Here we have a lot of atoms. Now you just visualize that we are hammering at one side, and now a thick sheet has been made into thin sheet. This is not possible with all the elements. Certain element, when we are hammering it, what will happen? That will collapse, that will break. But elements like gold or elements having the property called as malleability, they can be hammered into a thin sheet. Now he has taken a gold foil, a thick gold foil, and made into a thin, very thin gold foil, that is gold sheet. It is approximately having 10 to the power minus 7 meters. Now what they have done, they have kept the thin film over here. So what is the thickness? 10 to the power minus 7 meters. And this thin sheet, they have allowed to expose over alpha rays emission. I will explain what is alpha ray emission. So alpha ray, alpha, beta, gamma, these kind of rays will be emitted from radioactive elements. Now we are keeping a radioactive element bismuth inside a metallic brick, a lead brick for example. Why we are using lead? Because lead are able to absorb radiations. Now radiations will be emitted in all the direction, but whatever the radiations emitted by this in this direction will be absorbed by lead itself. Okay. Now the radiations will be coming through this direction. It won't be straight, it will be in all the directions. But what will happen? The alpha rays, I will explain you what is alpha ray. Alpha ray is nothing but a helium nucleus, He2 plus. So hydrogen is having, heliums are having 2 protons and 2 neutrons in the nucleus and 2 electrons in the first orbit. So only helium nucleus means there are no electrons with that atom. So having 2 protons and 2 neutrons, that's all. Now this helium nucleus, when it has been taken from a radioactive nucleus, that is called as alpha ray. I will repeat it. So this is a big concept, so I will make it very simple for you. Let's say a nucleus is having, for example, 100 protons and 100 neutrons, some random element. Okay. Now from here, when this nucleus undergoes a alpha emission, what happens? Alpha particles consist of 2 protons and 2 neutrons. Now when this undergoes an alpha emission, what will happen? This nucleus will now change to a new nucleus having 100 protons, right? That will become 98 protons and 98 neutrons. So these are nuclear emissions. Similarly, from the nucleus of bismuth, alpha rays will be emitted. So here only one concept is required. From radioactive element inside, alpha rays will be emitted outside. Now the emitted alpha rays will be going in all the direction, but the one which is not going in straight line will be accepted by the lead blocks. So only we will now have alpha particles going in this direction, in the straight line. Now when we allow alpha particles, this gold filament, gold foil, to get illuminated with alpha particles, Giger and Master has noted down all the observations. Now what are the observations? Where they have got the observation? On the other side of the gold filament, they have placed zinc sulfate screen. Why zinc sulfate screen have been placed? Because whenever alpha particles hit the surface, hit this element, there will be certain kind of sparks made. We can't see the sparks made. With the detector, it can be measured. For example, let's say if an alpha particle was able to go through this, now there will be an illumination created by the alpha particles, and that will collide on zinc sulfate screen. So once it reaches zinc sulfate screen, we can keep our microscope here or the instrument here and will be able to visualize that alpha particles have came and collided here, and that has done certain reaction here. Okay, so zinc sulfate is basically a detector to see the illuminations. How does the illuminations come? Illumination will only come when the alpha particles will be able to pass through the gold filament. Now, so is it possible, let's say we have an object here. Now when we, let's say I have a torch here. Now when I switch this torch on, will the light pass through the screen? No, because the light particles or the light photon cannot pass through this, because these atoms, basically when the light comes, the tendencies are it will allow it to reflect on the screen. Refraction will not be possible because this is not a transparent element. So what we are expecting that the light will not pass through this element. But what we have done initially, we have made into a thin sheet. So our expectation is the light ray will not pass to the other side. But in reality, Giger and Marsden have observed that the light ray was able to, that the alpha particle was able to reach here. It's not light, so I have just given an example here. Now the alpha particles has passed through this and has reached here. But not all the alpha particles. So this means it has no deviation. This is the direction incoming, and after passing through the gold filament, it is going in straight line, which means it has got undeviated. So these four observations was made by Giger and Marsden experiment. Okay. So I will explain one observation after other. First observation was most of the alpha particles, that is 99.86% went undeviated, which means from the radiations from the alpha particles coming from the experimental setup from this part, 99.86% of the alpha particles has passed through this. Okay. Now next observation was 0.14% of the alpha particles have deviated by an angle more than 1 degree. So some of them have deviated. What is the percentage from 100? If 99.86 go, what is remaining? 0.14%. Now 0.14%, see 0.14% has got deviated by an angle more than 1 degree. The next thing is 1 in 8,000 alpha particles deviated by an angle more than 90 degree. So what is 90 degree? This is the incoming radiation, right? That is alpha particles. This one is 90 degree. Above 90 degree, if you are taking 8,000 illuminations here, out of that only one is coming in this direction. That is more than 90 degree. And 1 in 10 power 6. 10 power 6 means 1. This one is 10 power 6 of alpha particles that has deviated with an angle 180 degree. What is 180 degree? This one is the direction has deviated in this way. That is collide and return back. I will explain all the observations once again. This is very, very important. What is the first observation? Most of the alpha particles, that is 99.86%, has passed through the gold filament or the gold foil without any deviation. Now second observation, what is remaining from this? 0.14% of the particles has deviated by an angle more than 1 degree. That includes more than 90 and more than 180 as well. So more than 1 degree how much? 0.14%. No, more than 90 degree how much? 1 in 8,000 alpha particles has deviated by an angle more than 90 degree. Now some have collided back, that is returned, head-to-head collision, came like this and returned back exactly in the same direction that has gone, in the same line that has came in. So this is the line, right, that has came in. Now in the same direction it has gone out. What is the number? 1 in 10 power 6 alpha particles. And what is the angle? 180 degree. So this was the observations made by Giger and Marsden. And with this observation, they have approached their master. Who is that? Rutherford. But Rutherford has initially rejected the observations. Why? Because he has seen the majority value, the first observation. What was the first observation? 99.86% went undeviated. He told that it is not possible. So if that happens, which means I am sending 100 alpha particle from here, out of that 99 will go undeviated, means there is nothing here. There is nothing in the alpha filament. It's everything empty. Let's say I have a mesh here. Okay, I am throwing 100 bolts inside to the mesh. Just a net you can consider. So if I am throwing 100 bolts, out of that, if 99 is going out, means I have nothing here. It's an empty space. But if I am having certain holes, let's say in the mesh, let's say this is the mesh, and I have certain holes, 2, 3, maybe 3 holes. Now in that mesh, all other space is occupied. Now when I am throwing 100 goalies, small balls, maybe 20 or maybe less than 20 will be going out, but all other have to come back. But here with this experiment, out of 100, 90, it's not only 99, 99.86. Now let me take a value of 10,000. So multiply this with 100. Out of 10,000 alpha particles, how many will go undeviated? 9,986. Only 14 will be deviated by an angle more than 1 degree. He has rejected this. This is not correct. Now, after that, he has clearly gone through all the observation and he has visualized. He has tried to analyze these two observations very clearly. See, though this process happened, though first and second things, it was difficult to, understand, or it was difficult to take forward by Rutherford, but these third and fourth point has opened his eyes. What is that? 1 in 8,000 alpha particles deviate more than 90 degree, and 1 in 10 power 6 alpha particles deviated with an angle of 180 degree. What does that mean? We know that alpha particles are having a positive charge. Why? Alpha particle is 2 proton and 2 neutron. So 2 proton, what is that? Plus 2e. That is the charge of alpha particle. Now if the alpha particle is coming back, one reason is it is having a mass of, let's say it has collided with a heavier mass. That's the reason it has returned back. Now why some of the alpha particles has deviated by an angle more than 90 degree? That is not only collision. That will happen when, let's say, if alpha particles are having a positive charge, and if the particle here where the alpha particle has collided with, if that is having positive charge, I will repeat, this will happen, third and fourth will happen when the alpha particles which collides with the particles and that one is having a charge of positive charge. If this one is having a charge of positive charge, alpha particle will come here, so this will repel, so it will go to the maximum distance and after that will deviate. Okay, and in the next case, one has deviated by an angle 180 degree, that has returned back, which means that will come and see a positive charge here, head to head collision, and that will return back. So these two will be true when the alpha particles, when this particle where the alpha particles has collided with has got heavy mass and positive charge. Now around this, Rutherford has made a conclusion. After accepting all these values to be true, he has made this conclusion. And the first conclusion is made with the first observation. What is that? Most of the alpha particles when undeviated. How the particles will go undeviated? When the space in an atom is empty. Correct. Let's say I will draw the gold sheet here. Okay. If the gold sheet is in this way, let's say we have a nucleus here, positive charge, and this is the atom, and another nucleus here, and this is a atom, the whole atomic size, and I have another positive charge here, whole atomic structure, another positive, whole atomic size, another one, whole atomic size. Now what is the first conclusion? Most of the space in an atom is empty. Now alpha particles, see, alpha particle will go through these empty spaces. These are empty spaces. The whole thing is an atom and it is having a positive charge inside. So only alpha particle, when it goes with head-on collision, that is when the alpha particle is going very close to the positive charges, then only that will deviate. But if the alpha particle is going in this way, no deviation, no deviation, no deviation, no deviation. See, you will get a lot of point where there won't be any deviation. So that is the first conclusion. Most of the space in an atom is empty. Let's say this is an atom and majority of the space is an empty space. Okay, now we have a positive charge here. The next conclusion is about the positive charge. And what are the observation? 0.14% of the alpha particle deviated by an angle more than 1 degree, and 1 in 8000 more than 90, and 1 in 10 power 6 more than by an angle 180. So he has told that if this happens, the deviation has happened because this was a positive charge. Now if this is a positive charge, now when do alpha particles comes in this direction, it sees a positive charge, that will deviate. Okay, it sees a positive charge, that will deviate. And when the alpha particles comes in a straight line, that will return back. Now I will draw a big picture of this one. So we have got a positive charge here. Now alpha particle is coming in this direction. Okay, this is very close to this. So what will happen? That will deviate by an angle more than 90 degrees. So this one is 90, more than 90 degrees. Now when an alpha particle goes in this direction, here the distance is more as compared to this distance, that will deviate by an angle more than 1 degree. That is, here in this case, alpha particles comes in this direction, that will deviate by 1 degree. So this one is the one which has deviated by 1 degree, and this one is more closer to the positive charge, those alpha particles, and that will deviate by an angle more than 90 degree. Now when they will return back, that is when the angle is, when it is a head-to-head collision in straight line. When the nucleus is in straight line with the alpha particles incoming, then that will return back by an angle of 180 degree. So here I will also mark one more thing, when it is very close to this 180 degree. Sorry, more than 90. So one thing is this one. See, here it has deviated by an angle more than 1 degree. See, came, it has seen the positive charge, deviated. Why it has deviated? Because alpha particle is too positive. And how much positive is this one? This is, the whole thing is gold, right? Gold is having an atomic number of 79. So this is 79 positive. Okay, so this has deviated by 1 degree, and here in this case, this has deviated by an angle more than 90. Why? Because here the distance is very close. Okay. Here in this case 180 degree, here the distance is 0. What is the distance? It has came head-to-head collision and it has returned back. Now one more confusion here. Let's say I have a cricket ball and another one football. Now if I am throwing a cricket ball on the football, what will happen? The cricket ball will hit the football and both will move, right? Now why, if at all, if this is positive charge, alpha particle is positive charge and this one is also positive charge, why can't these alpha particles get collided with this positive charge of, basically that is nucleus of gold, and why both can't move in line? In the way when a cricket ball collided with football, both will go in the same direction. It will get a velocity now, it will reduce the velocity and go. So this is before collision, after the collision both will move. Why can't this happen? Now I will give you an example. When the football will move, when they are having comparable mass. right? This mass will be able to give a motion to the other mass, which is football. But when I'm throwing a ball here on the wall, will the wall move? No. Why? Because the mass of the wall is very heavier than, maybe 10,000 or 1 lakh times heavier than the mass of the ball. So when the mass where it has collided is heavier, I mean more than 10,000 times heavier, then it will not go. It will not be able to give a motion to the other object. Like we are throwing a ball on the wall doesn't move. What will happen? The ball will return back. What is the conclusion? Because the wall has got heavier mass, heavier as compared to the other case. Okay, here in this case also it is heavier, but with the wall it is n times heavier, but here in this case maybe 1 or 2 times heavier. So that is the other conclusion. See, all the mass of an atom is concentrated at the nucleus. Now, with the deviation thing, that is with second and third thing, with the second and third observations, he has told that this one is positive charge. Okay, now what is the fourth point? It has deviated by an angle 180 degree, which means after collision it has returned back. Now why can't after collision both moves in line? Because this one is heavier. So what is the observation? All the mass of an atom is concentrated at the nucleus. This is very, very important. So I will explain the experiment once again. It was a gold film and the alpha particles have came and collided with the gold film, and after this alpha particles has gone. Some of the alpha particle has gone in straight line without any deviation. Some has deviated by an angle more than 1 degree, some an angle more than 90 degree, and some at an angle of 180 degree. You should be knowing this value. What are those sums I have mentioned here? 99.86, 0.14, 1 in 8000, 1 in 10 power 6. And these are the observations. Conclusions are very, very important. Let me repeat it for you. Most of the space in an atom is empty. That is the reason 99.86 has gone undeviated. Then what is the reason for deviation? That is the positive charge inside an atom is very small space, and the positive charged element is called as nucleus. Now see, the positive charge is in the small space. That is the reason only very less number of the alpha particles has got deviated. Now some have deviated by an angle 180 degree. Why? Because all the mass of an atom is concentrated at the nucleus, and nucleus is heavier, approximately 1900 times heavier as compared to the mass of an alpha particles. Sorry, mass of an electron. Okay, my mistake. Nucleus, mass of the proton is basically 1900 times heavier than mass of electron. So with that, we know, with that consideration, we know that nucleus is having, so this one is an outcome of modern physics. The one which I have told you, that is 1900 times mass of electron. But you can just consider with that, see 79 numbers of protons are there inside. So 79 into so many mass of a proton will be the total mass here. Now who is coming to collide? That is just 2 proton. Sorry, two proton and 2 neutron. So compared to this, it is very lighter. I can say that 100 times. Mass of a nucleus is, mass of nucleus of a gold filament is 100 times heavier than an alpha particles. Approximately, yeah, 50 times, sorry. Okay, thank you.